Here's the questions. Y equals to cubic root of x squared minus 2x. Right. Okay, first step, we're going to find our stationary point by using the first derivative. So first one, we find the derivative dy dx is equals to, we're using power rule, 1/3 and the x squared minus 2x to the power of negative 2/3. And don't forget chain rule, and then you times inside the derivative, which gives us 2x minus 2. Okay, and then I tally them up. Now you can see the derivative actually have denominator. So what does this gives us? We see x squared minus 2x to the power of 2 here, cubic root, right? So now, for station point as normal, what we do is we let first derivative equal to 0. We let dy dx equal to 0. So we go 2x minus 2, 3 outside with cubic root x squared minus 2x squared equal to 0. So how are we going to solve this equation? Pretty big. So first step, I'm going to remove my denominator. My denominator here is that. So how do I remove it? I multiply top and the bottom by the denominator, and left hand side also times by 3 cubic root 3 x squared minus 2x squared on both left and right here. Okay, which gives me, I'm going to put it in 3 cubic root x squared minus 2x to the power 2. So then I cancel the denominator here, and the other side 0 times that is give me 0. So it's coming for very simple, gives me 2x minus 2 equal to 0, and therefore my x equals to 1. And I'm going to sub x equals to 1 back into my y here to get my y values. So when x equals to 1, y is equals to cubic root of 1 squared minus 2 times 1, which give me negative 1. So therefore, I found my stationary point. Stationary point. At 1, negative 1. And no discontinuities. Yes, okay. Next step. So next step, step 3, we got to determine the nature of station point. For the nature of station point, this time I'm going to using the sign change of the first derivative. So it's different from the other videos. So first derivative, I'm going to using the sign change because second derivative is pretty big. So I'm going to stay in the first derivative without using the second derivative. So I have the starting point at x equal to 1. At that point, my first derivative equal to 0. So from 1, the left-hand side, I'm going to choose negative 1, and the right, I'm going to choose 1.5. And I sub in negative 1 into my first derivative will give me big calculations, will give me negative 0.64. And I sub in 1.5 into my first derivative will give me 0.40. So what does that mean? It means first derivative on the left of 1 is actually decreasing, and at 1 is actually stationary point, and positive means increasing. So what does that mean? It means my nature of the stationary point is, therefore, 1 and the negative 1 is a minimum. As you can see, the shape of the curve from my previous drawing is minimum turning point. Yeah, like here. Down, flat, and up, minimum. All right, okay. So now let's move on. Step 4. So step 4 is the harder part. As you noticed before, our first derivative here is having different things. We have denominator has x in it. What does this gives us? It's possibly we'll have denominator equal to 0, which make a first derivative undefined. When the first derivative undefined means the gradient of tangent undefined, means we have a vertical tangent. So for vertical tangent, we let denominator equal to 0. Of dy dx equal to 0. Okay. So my denominator was that 3 and the cubic root of x squared minus 2x all squared equal to 0. Then I divided by 3 on each side, so it gives me cubic root of x squared minus 2x all squared equal to 0. Looks still pretty big, and then what I do, I can cube both sides and get rid of the cubic root. That equal to 0. For the number after square be 0, which means the number itself to be 0. So then I can factorize the x out. I get x minus 2 equal to 0. Finally, therefore, I'll have actually 2 points which give us a vertical tangent where x equal to 0 and x equal to 2. And again, I have to sub back into my original question, which is y equals to cubic root of x squared minus 2x. Subbing x equal to 0 give me y equal to 0. And subbing x equal to 2 give me y equals to 0 as well. So actually, I have 2 points as vertical tangent. So this is my vertical tangent. At 0, 0, and 2, 0. Right. Okay, so I get everything ready now. Let's start to sketch. Okay, we get enough space. Let's sketch. So I put my number plan here. So y-axis, x-axis, 0. So first point I found was 1 and negative 1 as my minimum turning point, which was, yes, had this point here. So I go, yeah, that's my staging point. And I also determine the nature of staging point is a minimum turning point. So it's going down and flat and going up. So let's see. So at this point, it's going down and flat and going up. So that gives us minimum turning point here. Now the next one is my vertical tangent. That's a pretty interesting one. So what does that mean, vertical tangent? At the 0, 0 here, the curve using this line is a tangent. And also at 2, 0 here, 2, 0 here, the curve using that vertical line as a tangent. So now we get this O point, and also this vertical tangent at these 2 points is also the x-intercept. Very good. We don't have to find another x-intercept. That's all we need. So now let's join them together. And the curve has to go smooth, and you can see I try to make it using that line as a tangent, and it goes. And here using this line as a tangent. And it goes. Yep. So that's final answer of the sketching. Have to make smooth and nice, no wonky. Beautiful. Finish.